Hi, my name is Sai Shiranya and I am here to talk about my course project titled as Document Classification Using SPACY, which is a part of an information retrieval course. And this presentation covers and explores how natural language processing techniques, specifically SPACY's text categorization module, can be effectively used to classify documents automatically. Document classification is a key component of information retrieval and helps organize, search, and understand vast textual data efficiently. Over the next few slides, I will explain the concept of information retrieval, the fundamentals of document classification, how SPACY implements these techniques, and the future directions in this domain. And I want to talk about SPACY NLP framework and the steps involved in building and evaluating a text classification model. I will also share practical applications, challenges faced in real world scenarios, and future directions in this field. This presentation aims not only to describe the implementation process but also to provide a deep understanding of how natural language processing supports intelligent information systems. Coming to the next slide, information retrieval or IR refers to the process of obtaining relevant information from large collections of unstructured data such as documents, web pages, or articles. The main goal of information retrieval systems is to retrieve documents that satisfy a user's query. Traditional information retrieval systems like search engines rely on keyword matching, whereas modern information retrieval systems integrate natural language processing and machine learning to understand the meaning and context of queries. The applications of IR include web engines like Google, question answering systems, document ranking, and recommendation systems. Understanding information retrieval is essential as it provides the foundation for tasks such as document classification, which we will discuss in this presentation. And the primary objective of information retrieval is to help users find meaningful information based on their queries. As data volumes continue to increase at an unprecedented pace, information retrieval techniques play a crucial role in converting raw textual data into actionable knowledge, improving productivity, research, and decision making. Document classification is a supervised machine learning task that involves assigning predefined labels or categories to text documents. The goal is to automatically determine the subject or type of a document based on its content. For example, an article titled Apple launches new iPhone can be classified as technology, while government passes new policy may fall under politics. This process significantly reduces human effort required in sorting, filtering, or organizing large volumes of text. Document classification is used in various domains, including news filtering, email sorting, and academic literature categorization. Manual classification of text is labor intensive and prone to error, especially when dealing with large data sets. Automated document classification brings consistency, efficiency, and speed, making it an integral component in many modern data-driven systems. The importance of document classification. This arises from the exponential growth of digital text data. Every day, organizations generate large amounts of unstructured text in the form of emails, reports, reviews, and messages. Manually managing this data is inefficient and error prone. Automated classification systems solve this challenge by organizing documents according to topic, sentiment, or relevance. Some common use cases include spam detection in emails, sentiment analysis for product reviews, and automated tagging of customer feedback. It also enables quick information retrieval, which enhances decision making and business intelligence. In healthcare, clinicians use automated text analysis to organize medical records, clinical notes, and diagnosis reports efficiently. Legal firms extract and categorize case files to speed up case preparation and research. This ensures consistency across decisions and improve overall system accuracy, especially in large-scale data management environments. Coming to text classification pipeline or process. The text classification process typically follows a structured pipeline. First, the text processing is performed, which involves cleaning, tokenizing, and removing unwanted elements like punctuation or stop words. Next step is feature extraction. This converts the clean text into numerical representation such as word embeddings or bag of word models. And coming to the third step, which involves model training, where machine learning or deep learning algorithms learn patterns from labeled data. Once trained, the model is evaluated using metrics such as accuracy, precision, recall, and F1 score. Finally, the model is deployed into a real-world application where it predicts categories for new upcoming documents. Popular feature extraction methods using TF, IDF, and word embeddings. We then train a supervised learning model using labeled examples. The model learns relationships between input text and category labels. Finally, we evaluate the model using metrics like accuracy, precision, recall, and F1 score to ensure reliability before deployment. Then coming to spaCy. spaCy is one of the most powerful open source NLP libraries developed in Python by Explosion AI. It is designed for production level use and provides fast, efficient, and accurate text processing. spaCy includes built-in components such as tokenizers, part of speech taggers, dependency parsers, and named entity recognizers. Its modular architecture allows the addition of a text categorization component, which can be trained to classify documents into multiple categories. spaCy also integrates seamlessly with deep learning frameworks like TensorFlow and PyTorch, making it ideal for research and practical applications in natural language processing and information retrieval. One of the spaCy strengths is that it integrates easily with deep learning libraries. This makes it highly flexible for building scalable applications of natural language processing. It is widely used in industry for chatbots, recommendation systems, information extraction platforms, and intelligent document processing tools. spaCy NLP pipeline or process. It processes textual data through a sequential pipeline consisting of multiple linguistic analysis components. It begins with tokenization, where text is split into smaller units called tokens. The part of speech tagging module assigns grammatical categories to each token, such as nouns, verbs, and adjectives. The dependency parser analyzes syntactic relationships between words, while the named entity recognizer identifies entities like people, locations, and organizations. Finally, the text categorizer component uses statistical or neural models to assign labels to the document based on its content. This modular pipeline enables end-to-end document classification efficiently. Together, these elements enable spaCy to understand linguistic patterns and perform complex text-based tasks efficiently. To implement data of the document classification in spaCy, we first install the spaCy library and create a blank English NLP pipeline. We then add a component called textcat multiple label to the pipeline, which supports multi-label classification. Each label, such as sports, tech, or politics, is explicitly defined using the add label method. This setup allows the model to handle multiple categories simultaneously. This simple yet powerful initialization forms the foundation for building custom text classification models in spaCy. This demonstrates how spaCy can be used as a foundation for more complex models in real-world scenarios such as multi-topic news classification or automated document systems. In the training process, we prepare labeled text samples that associate a document with one or more category labels. For example, the sentence football match was thrilling is labeled as sports, while Apple released new iPhone is labeled as tech. The training loop iteratively updates the model using the NLP.update function, optimizing its internal weights based on the provided examples. This process helps the model learn distinct linguistic features that differentiate between topics. Over several epochs, the model becomes proficient in recognizing unseen text accurately. These labels inform the system about the output categories it includes or needs to predict. This setup prepares the spaCy environment for training and classification. After training, the model can be evaluated using new text inputs. For training, we can pass the sentence Samsung launches new Galaxy phone. It turns probabilities for each category such as sports 0.02, tech 0.94, politics 0.04. The highest probability corresponds to the predicted label, which is in this case is tech. This output demonstrates spaCy's ability to perform accurate document categorization based on semantic and contextual features learned during training. To train this model, we created a set of label sentences. One if the sentence belongs to the category, or 0 if it does not. A football related sentence receives a value of 1 for sports and 0 for other categories. This label dataset helps the model learn how text features relate to specific classes. The model performance is typically assessed through accuracy metrics and visualized using tools such as confusion matrices or precision recall charts. In our example, the SPACY classifier achieved an accuracy of approximately 92% on validation data. This indicates that SPACY's text categorizer performs effectively, especially for small and medium-sized datasets. Visualizing results not only confirms model reliability but also helps identify areas for improvement such as class imbalance or data noise. Our model achieved approximately 92%. This strong performance indicates that SPACY's text categorizer is effective with a relatively small dataset. This can be further assessed and helps identify strength and weakness across classes. Coming to applications and challenges, document classification using SPACY has multiple applications including automated text categorization, sentiment analysis, and customer feedback tagging. However, it also faces certain challenges. One major issue is the requirement for high quality label datasets, as training data largely determines performance. Handling ambiguous language, sarcasm, and domain specific terminology also remains difficult. Furthermore, biases in data can lead to skewed predictions, highlighting the need for ethical model design and evaluation. Continuous refinement and responsible AI practices are essential to address these challenges. Bias in training data may also affect predictions. The performance can drop when handling ambiguous or sarcastic language. The future directions or future research can enhance SPACY's text categorization by integrating transformer-based labels or models such as BERT, Roberta, and GPT. These models leverage contextual embeddings to achieve superior understanding of semantic relationships in text. Combining SPACY's efficient pipeline with transformer-based encoders can significantly improve classification accuracy and adaptability across domains. This hybrid approach bridges classical natural language processing techniques with state-of-the-art deep learning, paving the way for advanced scalable AI systems. As AI evolves, classification systems will become more accurate, interpretable, and adaptable. This is a growing interest in domain-specific labels for finance, healthcare, and legal industries. These models support deeper context learning and significantly higher accuracy. To conclude, document classification plays a fundamental role in the field of information retrieval, enabling automated text organization and retrieval. SPACY provides a robust and scalable framework for building efficient NLP applications, including document classification. By combining SPACY with modern deep learning techniques such as transformers, we can achieve even greater performance and contextual understanding. References used in this presentation include SPACY's official documentation, the Explosion AI GitHub repository, and the relevant research papers on text classification techniques. Thank you, and I want to end up my presentation by here.